Welcome to our last lesson in Unit 13, and this lesson is on the distance formula. Again, this is our last lesson in Unit 13. The content area that we're focusing on for this standard is applying the Pythagorean theorem to find the distance between 2 points. So that's what we're going to be doing today. We're going to apply this Pythagorean theorem right here in order to determine how we can figure out the distance between two objects using this formula. And so the lesson objective is basically that you'll be able to apply the Pythagorean theorem to finding the distance between 2 points. So let's talk a little bit about this distance formula here. First, if you have 2 points on a graph, such as 5.2, this right here is 5.2, and then this one would represent 5.6, you can find the distance between them by simply counting the units on the graph, since they line a vertical line. So I can literally just count that this is 1, 2, 3, 4 units. The distance between these is 4. So that's pretty simple, right? And even the distance between these 2 points, I can count what that distance is. The distance will be 1, 2, 3, 4, 5. Again, one thing you want to know also, that distance is never negative. Distance is not negative, so you can count from right to left or left to right. It does not matter. Distance won't be negative. Those two were pretty simple. Now we're going to talk about how we derive the formula for calculating distance. Okay, I know it's a lot, but let's take it one step at a time. Well, first of all, we should recognize this right here. C squared equals A squared plus B squared from the Pythagorean theorem. So what you do is you create a right triangle around the 2 points. So this is one point, this is another point. We create that triangle around them, and then it begins to make sense that the distance is really just the hypotenuse. That, that D right here stands for the distance. So the length, or the leg, is basically y squared minus y1 for one leg, and x squared minus x2 minus x1 for the other leg. When we put that into our equation here, you see the x2 minus x1 squared, that just represents one of the legs, and the y2 minus y1 represents the other leg. We take the square root of it, just like we would with the Pythagorean theorem, to find distance D, or to find that C. And so that's basically how we derive the distance formula from the Pythagorean theorem. So they took, and the hardest part probably is just knowing your points. So here, 5, 2, our point here, oops, I forgot to label that, but that's fine. We had our x2 was 5, so this would be our x2, and our our y2 was 6, so we look for 5, 6. So this was our first point here, our second point here, and this was our first point here, which would have been 2 and 2. Okay, now again, we use that square root sign because distance can only be positive. So that square root sign is also another way to make sure that our answer is positive, because we can't square a negative. That would be an imaginary number, and so therefore that's why we use that square root sign also. So we take it, and then we figure out the distance is only 5. So you subtract first, subtract both in the parenthesis first. We do the orders of operation. Then you take the square of the number in the parenthesis, and then you add them together. And then the final added number will be square rooted, and that will give us the distance of 5. It's a pretty straightforward formula. It's just may look a little weird because you see that square root sign, but just know you've already been doing that if you have been solving for C using the Pythagorean theorem. So you can find the distance D between any 2 points, x1, y1, and x2, y2, using the formula below. Again, x2 minus x1 is just how far between they are on the x-coordinate. It's basically we're finding the length of that leg, and we're finding the length of this leg by taking those coordinates and subtracting them. So you definitely want to memorize this, or you want to write it down as you do some of the assessments in Unit 13. So again, here's another example. When you're given only 2 points, we're going to use this formula. Find the distance between point 1, -4, -7, and point 2, -5, -2. So this right here, again, based on what we've already done from this formula here, we're going to look for x2 minus x1. So x2 is this -5, and x1 is the -4. So we have -5 minus a -4. Then again, we have y2, which is the -1, and our y1 is the -7. So we have -2 minus a -7. Anytime we have two negatives that are subtracting each other, we make it a positive. So this is where the positive comes in both of these. -5 plus 4 gives me a -1. And -2 plus 7 gives me a +5. I'm going to take the square of the -1 and get a 1. Take the square of the 5 and get a 25. You take the square root of 26, and that is roughly 5.1. So the distance between those 2 points would roughly be 5.1. You can try to do this one on your own. And in class on Tuesday, we will show you if you got this one correct. Again, this could be your first point, your x1, your y1, your x2, your y2. So go ahead and try to work this one out, and let's see if you got it right on Tuesday. That's going to conclude distance formula, and that's going to conclude Unit 13. So go ahead and try to take the lesson assessment for the mid-distance lesson, and you'll be finished with Unit 13. Make sure you K-mail me once you've finished lessons 1, 3, and 5 so I can give you credit for the entire Unit 13. Have a great Monday.